Okay, so here's the damaged strut, or at least non-working strut of my BMW. I got the new one on now, at least the second-hand replacement on, and it's working fine. So I did try to record some of that, but I don't know, I completely screwed up the video and lost some of it as well. So sadly, I'm not able to put that up sensibly. Anyway, I thought we were taking this apart just to see what's inside and how it works. So yeah, see what we can do. So here's the plastic guard for the some of the crud at least off the damper system. All these screws are stainless, by the way. So yeah, this doesn't really do anything useful. It's just a clip for the cable, and obviously the stress relief arrangement. Yeah, these Mara tools, these Torx ones, are really good. They do some hex keys as well, which are actually quite unique. They aren't just a parallel hexagon. They have curvature on them, which actually helps them to stop kind of camming out. And I would thoroughly recommend them. As you'd expect, I guess they're quite expensive, but relatively speaking, but worth every penny. This one's stiff for some reason. These Torx ones have a kind of ball end as well, on certainly the bigger sizes. So there's a ball end on that, similar to some hex keys. So again, that's quite handy when you need to get in at an angle. Okay, so finally got the screws out, and there you go. That's quite nicely sealed. Some kind of foam, closed cell foam gasket, slightly detached there, but not too much. But it's pretty clean inside, nice and clean and dry. And inside, sure enough, there's a motor and gearbox. Just slightly loose, interesting. Not sure that's deliberately loose or not. Doesn't look it. Well, that is distinctly loose on there. It could just be deliberate so that it's compliant and all the joints line up, but that's a bit peculiar. Anyway, straightforward motor. I can't see any feedback on it, so it doesn't seem to know where it is, if you know what I mean. Although maybe there must be something that tells it where it is. There's too many wires otherwise. There's a positive and negative plus two other wires. I guess the other two must be either just some switches to move it between specific positions, or some kind of servo mechanism. But that clearly drives some rotating valve, perhaps, that's contained in here. Okay, interesting. So far so good. I wonder if I can get the motor off easily. It's not obvious how to get to the back side of it. There's a clip on here. Maybe that's the answer. A circlip. It's just a plain circlip. Sure enough. Okay, so there's a hex drive there, and clearly hex spindle there. I'll just slide it out. So that entire motor drive just lifts off. So that explains why it was loose, which is fine. So just retained by that single clip. Some kind of plastic. It's pretty hard plastic. I wonder whether that's the whole gear that's plastic. And a worm on the motor spindle. I'll maybe take that apart later. Some pins in here. Yeah, this. Okay. So the pins I could see on the outside are actually loose and just slip into these holes here as a dowel. So it's located pretty firmly. There's this little washer as well. Oh, sorry, gasket, not washer. Where was that? It was there, wasn't it? Yeah. Okay, that's just aluminium. I guess there could well be pressurised gas in this, so might be as well to be a bit cautious. Fits there. Escaping gas sound. So again, yeah, this is some kind of filling cap with an O-ring on it, and it looks to have red fluid in it. Interesting. The one here definitely had blue fluid in it. This one, sure enough, yep, is red. Kind of surprising. Yeah, it's definitely red, quite low viscosity. Okay, so I've been pretty brutal here. I obviously need some kind of special tool to compress the spring and get the strut apart. So, given that I'm never going to use this again, I've taken the brutal approach of just cutting through the spring with a angle grinder. So that should allow me to get this end off, which it obviously does now, I think. So there's a polyurethane bump stop there, and this little C clip should come out. There we go. So I think now this whole spring should come down off the strut itself. Okay, so with the spring off, this top joint here, which is just threaded with this reservoir on it, that does turn now. Oh, there you go. So it looks as if this top will come off. Okay, so this collar with the screw jack on it has moved right down, which gives me a chance to get this all the way around, and it releases. So there we go. It looks as if this is just simply a reservoir with a small hole through to the top of the damper unit. So I would assume that this just acts as an additional spring in effect. there may be some kind of membrane in here, but presumably it's just pressurised with nitrogen and applies a pressure onto the top of the oil column in the damper. Nice O-ring in there to seal onto this section here. Looking down the top of the strut, yeah, you can see a piston arrangement there, which I guess is attached to this. Yeah, and that's directly attached to the bottom end. So the outstanding question is how this wire gets anywhere and what it does. Getting there. Okay, so sure enough, knocking this down, this whole collar arrangement has come off. So this is obviously some kind of jack, in effect. Yeah, it's got some O-rings in there, which pick up on this chrome surface. And there's a ridge at the top end here. So I guess once the collar is on, it can't go any higher than that. Yeah, and there's a lip there for the that top of that chrome section to fit into. So yeah, that gets wedged hard up against there. And then I assume that as the spindle is turned, this inner ring must jack itself out. Okay, so this cap, I managed to get it out just by twisting it, and it seems to have no means of support, as it were. There's no thread, no real seal either, so it just seems to be pressed in, which seems strange. Maybe it's held in with Loctite or something, but there's certainly a seal in there, and the piston assembly, in fact, looking at it, looks as if there must be a circlip around there, stopping that from coming out. So again, that's the next challenge. Yeah, I need to work out how to get that circlip out. That was a pain to get out, but simple circlip. So hopefully this whole thing is clear now. Whoop, there we go. Oh, bit of oil. So, simple tube, well not a simple tube really, it's a tube, but it's also got this quite complicated collar arrangement on it, which I now realise is what the ride height adjustment runs on. Okay, good. Okay, losing patience now, so time for the angle grinder. To make some sense now. These are the components laid out, reviewing some of them. So the height adjustment for the ride height and the luggage pillion, no pillion, that business, is all down to this jack. There's a hex drive on one side, which obviously just moves this jack in and out, fits onto this chromed section of the strut. There's a circlip around there which it butts against, like so, and this motor just hangs off the side with its hex drive here. So that's relatively straightforward. The 4-wire connector is the one that goes to the motor, so I guess there's positive negative power, and these other 2 wires must be some kind of limit switch. I haven't taken this apart yet, I probably won't, but there must be some kind of limit switch in there to allow it to move to one of the 3 positions. So that's good. Is it 3 positions or 4 positions? Anyway, that seems to be that. Completely independently of that is the damper adjustment, and that's controlled by the 2-wire. I think it's 2 wires, might be 3, on the bottom end of the strut. So that wire simply comes in the bottom of the strut. While we're down here, this is just a 1/4 cut out. The bottom mount is solid steel, but it's on a sort of spherical ball arrangement so that it's got some freedom to pivot, and there's an elastomer of some kind around the outside to give a bit of resilience. Anyway, the wire comes straight up through the rod, which is actually a tube, and this is the plug that fits into the bottom of the tube we talked about earlier. Just a press fit, which still surprises me, but still, so maybe it's Loctited as well. Then there's this piston arrangement here, which, remember, did have the polyurethane bump stop located on the outside here. You can see that through the spring. So we've got this sliding shuttle device here running up and down the tube in the oil. There's a washer here which has got, say, sort of a pattern on one side but not the other, so that's doing something to control the fluid. Meanwhile, we come up to this unit here, which actually contains the coil. There's a solenoid coil in there. You can just see the copper windings. I'm going to stay still a minute. There we go, so there's copper windings here. And sitting inside that is this assembly. So that just runs into there. It screws in, this threaded area screws into the threads here. So that's located down into there. And interestingly, and this is cut off the top here, but I don't know if you can see it on the camera, but if you look at this, on here, if you can see, but there's a brass section here and then steel either side. So somehow they've managed to manufacture that so that there's a piece of brass sort of bonded or welded to the steel either side. I don't know how they would do that. Maybe some sort of electron beam welding or something. But to get two completely dissimilar metals so intimately bonded and welded, that's pretty clever stuff. Anyway, I think that is so that this brass section is non-magnetic. So you've got a magnet either side, and you've got this shuttle inside. So I'm assuming to get the three settings, this shuttle is either drawn down to the bottom, or it's pushed up to the top by the coil, and then finally maybe it is suspended in the middle. So that would give you the three settings, and that then controls the flow of oil through this assembly at the top. This piece here fits on the top and's got a static but quite complicated valve arrangement in it. I'll come back to that in a minute. Meanwhile, this assembly here actually has, I don't know whether you can see this, but there's a hole here which is just for a roll pin, which it seems to orient this unit in the base of the strut. But here there's a small O-ring and a passageway, so that obviously seals against a similar hole down here. And sure enough, I hadn't noticed it before, but there is indeed a hole on the inside of this unit. Oops. Down here. So I would think that is some kind of pressure equalization arrangement to keep this floating part moving freely, not pushed to one end or the other by the differential pressure across it. That's a guess, but yeah, that could well be the case. Meanwhile, there's a little brass screw in the bottom, which seems to adjust the position of the shuttle. So that just screws in, and if it's screwed in, it moves this shuttle up or lets it relax back down. So I guess that's some kind of calibration screw that would have been set at the factory. So I don't understand how this valve works at the top, but I'm assuming again that the flow of oil through these holes and through the centre is dependent on the position of this solenoid arrangement. So effectively it's a variable resistance valve that's letting oil from below the piston down here in the strut flow up here through these holes and out the centre. So with varying resistance. Meanwhile, this cap fits on the top of that, screwed on. So it has a fixed valve assembly in it, which is actually surprisingly complicated. It's actually got it's got a thick washer here and a thick washer at the top, and it's held together this rivet through the centre, and it sandwiches a disc, which itself is quite complicated. So this disc here, where is it? There we go. This is the piece that I've cut out, the quarter. And again, I don't know if you can see that, I've put it on here. There's a complicated pattern in this. It looks as if it was plastic, but it's actually not. It's got some kind of surface treatment that makes it look grey. But it's actually probably sintered, but definitely metallic. But it's got this very complicated series of cutouts and lands and holes in it, different on each side. On this side, for instance, there's these little dots on here. So someone spent a lot of time working that out, I guess. And as I say, that disc, complicated looking disc, is in the centre of this stack of washers. So on either side it's got the thick washers top and bottom, but then it's got a whole collection, it was 7 of them in total, of these thin, almost foils, different thicknesses. One of them's got a dark finish, and it's actually got numbers printed on it. So it's got a 5 on there. So again, that might be some kind of calibration thing. They might pick different washers to set the thing up differently. So again, I'm assuming that this so it's a fixed valve, it's not modulated by the solenoid in any way, but I'm assuming that it allows oil to flow through the centre and through this annulus and escape out the top in a controlled way, probably different in one direction than the other. So on the outside of that, this piece is looks like nylon piston ring in effect. I think that was just moulded on or pressed somehow, shrunk on perhaps, onto the outside of that unit, and that provides the seal to the bore of the strut. So that whole assembly sat on top of there. So that's the widest point. So everything here is a smaller diameter than the tube, except for this top piece. So that's how I think oil can get past this solenoid area and into these holes, and then up through this valve in a controlled way. So there you go. It's quite a complicated unit. You can see why it's expensive, but also difficult to get apart and difficult to repair, I think. I can't see any sign of why mine had stopped working. That seems very strange. Nothing's obviously broken or no seal burst or anything, although having said that, having cut it up, it's difficult to tell whether that's true or not. But there's certainly no obvious problem. I guess it could be that the solenoid had failed, a broken wire. But I don't see why that would give me zero damping, or virtually zero damping. I think the only thing that would be likely to cause that is something to do with the blown O-ring or something, or yeah, strange. Anyway, I think that's about it for now. Good.